Okay, we're going to take a look at number 1 is the ln of 5x times the 9th root of 1 plus 2x divided by x minus 6 to the 7th. It does say x has to be greater than 6, but you can ignore that. It's just a domain restriction. We don't need that for this problem. We're just going to separate everything out on top by anything being multiplied. Couple of notes. First note is that the 9th root of 1 plus 2x is the same as 1 plus 2x raised to the 1/9. That's worth noting, so I can write this out like this as the ln of 5 plus the ln of x plus 1/9 the ln of 1 plus 2x, and then minus 7 times the ln of x minus 6. The reason that is so is because right here, notice that this can be written as raised to the 1/9. That's where the 9 comes from. Any exponents can come out front, and you separate everything being multiplied by on the top with a plus sign, and anything in the denominator gets a minus sign in front. And notice that has a 7 there, which came out front of the ln right there, and that's just ln, 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 ln. And that's the answer right there for number 1. Just expressing it as a sum and difference of logs. Number 2, we're going to basically go the same type of problem, just in reverse. So what I'll do is I'll have number 2 here. We'll say 4 log, get that fixed there, log 6 of base 4 plus 1/4 of log base 6 of x minus 3, and then minus 1/2 log base 6 of x. So I'm going to make a single log here, base 6. Notice they're all base 6. I'm going to take this 4 and move it back up here, so 4 to the 4th. And since this is positive, it'll be on the top of the fraction. This is also positive. I'll put a x minus 3 raised to the 1/4 there. And since that's in the negative, this 1/2 will come up, it'll be x to the 1/2 on the bottom because of that negative sign. And then just to clean it up here, I have log base 6. 4 to the 4th is 256. That stays as the 4th root of x minus 3. And on the bottom I have the square root of x. Whoops, this should not be under there. It should be under here like this, the square root of x. And this is your answer right here. Okay. Number 3, we have 15 log base 3 of, I'm going to write this as x to the 1/3. I know it says the cube root of x on the paper, but that's the same. Note that the cube root of x is equal to x to the 1/3. That's an important note. Then we have plus log base 3 of 15x to the 9th, and then minus log base 3 of 15. Okay, so here's what I'm going to do. I'm going to write a single log, base 3, make a fraction. Anything with a plus sign goes on top. Don't forget to move that 15 up here. So that's x to the 1/3 raised to the 15. And then this will be times 15x to the 9th. That's a funny looking 5. Let me fix that. And then, of course, this will be 15 on the bottom because that's a negative sign. All of these are log base 3. Cleaning this up, I have log base 3 of x to, well, 1/3 of 15 is 5. I have an x to the 9th. Notice this 15 cancels that 15. And this is a 3. Very bad handwriting, sorry. Fix that again. 3. And now I can simply say this is log base 3 of x to the, well, what's 5 plus 9? 14. And there's your answer right there for number 3. Number 4 and number 5. Number 4 looks like this. Log base 4 of 2.6 is the same thing as log 2.6 divided by log 4, where this is log base 10. And let me see, I'll use my calculator right here and simply say the log of 2.6 close parentheses, divided by the log of 4, close the parentheses, and on the calculator, I get this is, well, we'll just go take it to 4 decimal places, 0.6892. Actually, it would go up to 3 if I round it. I don't know if you can see that. Okay, and that's the same thing for number 5. I'll write this out. I have log base 3 of 25, which should be log of 25 divided by log of 3, which is equal to, again on the calculator, log 25 close parentheses divided by log of 3, and I get this number right here, which is 2.9299, and I'll just stop there. 2.9299, that's good enough. Okay, hope that helps. Okay, for number 6, we have number 6. It's a log of 5x equal log 4 plus log x minus 1. I'm going to say log of 5x is equal to log of 4 times x minus 1. Let me show you that when you have a plus sign, you can put the two logs together with a multiplication sign. If I clean that up a little bit right here, I have this. That would be 4x minus 4 inside here. Now, since we have two logs, I can drop the logs and say 5x has to equal to 4x minus 4. And I can subtract 4x from both sides, 4x from both sides to get x equals to minus 4. This would be the answer, and I believe the answer guide says this is the answer, but the answer key is wrong. Because if you take this negative 4 and you put it into here, you get the log of minus 20, and that is no solution. So this has no solution, even though the answer key says it does. At minus 4, the actual answer is no solution. Number 7. Here I have log base 3 of x plus log base 3 of x minus 24 is equal to 4. This one is significantly different from this one because we have something over here, to specifically this number 4, maybe look a little better, that is not a log. So I'll combine the logs here to get log base 3 of x squared minus 24x. That's just multiplying those two together, and this will be equal to 4. Now we have to rewrite this as an exponential equation by taking the 3, raising it to the 4th power, and setting it equal to that. So I get 3 to the 4th power is equal to x squared minus 24x, or x squared minus 24x is equal to 81, because this 3 to the 4th is 81, or x squared minus 24x minus 81 equals to 0, and this becomes x minus 27 times x plus 3 is equal to 0. 27 times 3 is 81, and 27 negative plus 3 is negative 24. So 27 and negative 3 are the possible answers, but this one, because of this right here, I cannot use, so the only answer is x equals to 27, and that's the only one that works. Okay. Number 8 here, we do number 8. We have log base 4 of x plus 4 is equal to 4 plus log base 4 of x minus 1. Okay, I need to move that back over here so I can get both logs on the same side. Plus 4 minus log base 4 of x minus 1 is equal to 4. I just moved this term over to this side by subtracting it. Now it looks an awful lot like number 7, except that's subtraction instead of addition. So we'll divide instead of multiply. It'll look like this. X plus 4 over x minus 1 is equal to 4. Then we'll raise this up like this. We'll say 4 raised to the 4th power is equal to that. That's how you turn a log back to an exponential. So 4 raised to the 4, 4 raised to the 4, is equal to x plus 4 over x minus 1. Of course, 4 to the 4th is 256. We saw that in a few problems back, actually. And this is equal to x plus 4 over x minus 1. I'm going to multiply both sides by x minus 1 to get 256 times x minus 1 is equal to x plus 4. Just multiply both sides. That's supposed to be a 1. Sorry, x minus 1 here, and on the same thing on this side like that, so that these cancel, and that's all I did. Distribute, so 256, let me come over here in the center. 256x minus 256 is equal to x plus 4. Subtract an x. And I'm going to add 256 to get 255x is equal to 260, and then divide 255 x is equal to, well, it's both divisible by 5 for sure. Let me just check on the calculator real fast since I'm being a bit lazy, and I can do this faster on my calculator anyway. So it is 52 over 51. 52 over 51. That's just using the calculator to divide that out. Okay. And yes, you can use your calculator on the fly. Okay, there's number 8. For number 9, please note that 5 to the 4th equals 625. So you could write this as 5 to the x equals 5 to the 4th, which means x equals 4. And on number 10, the big note is that 2 to the minus 4 is the same thing as 1 over 2 to the positive 4, which is 1 over 16. So I can write this as 2 to the 5 minus 3x equals, well, 2 to the negative 4. That means that 5 minus 3x has to equal negative 4. So if I subtract 5, I get negative 3x equals to negative 9. Divide by minus 3. That's a 3. You get x equals to positive 3. There's your answer. Right there for 9 and 10. For number 11, there was actually a misprint on the review also. That box right there on the review says 3. Actually, it says a bunch of other things too, and this is what I intended right here. So I want you to see that. First of all, change the second function to 2 to the minus x plus 4 and set them equal to each other. And then what I'm going to do is I'm going to take the ln of both sides like this, so that I can move this entire exponent out front here and this entire exponent out front there to get x plus 2 times the ln of 3 is equal to negative x plus 4. There's a 4 times the ln of 2. Now we're going to distribute this ln of 3 to both things inside there to get x times the ln of 3 plus 2 times the ln of 3 is equal to negative x times the ln of 2 plus 4 times the ln of 2. That's a 4. Just a distributive property. Now I'm going to group everything that has an x in it on the left-hand side. This one has an x right there. So x ln of 3. This has an x right there. It's negative, so over here it'll be positive when I add it to both sides. And ln of 2. Now over here I still have a 4 ln of 2. And I'm going to subtract 2 ln's of 3. In other words, this one came over here and became positive. This term went over there and became negative. Then I'm going to factor out an x. Ln of 3 plus the ln of 2 is equal to 4 ln of 2 minus 2, that's a 2 inside there, 2 ln of 3, and then I'll just divide both sides by the ln of 3 plus the ln of 2, 2. These will cancel, and x will be equal to that, which you'll have to punch into your calculator. And we'll do the parentheses, 4 ln of 2, close parentheses, minus 2 ln's of 3, close parentheses, and then close for the top, divided by parentheses, ln of 3 close parentheses, plus ln of 2. Close parentheses to get 0.3211168. You can just bring it to, say, 4 decimal places. In this case, it'll be fine. Okay, so that's 0.3211, all done inside my calculator. Don't forget to use parentheses where you have to. Okay. For problem 12, I have 8 raised to the 3x minus 1 is equal to 1 over 64. Take a note over here that 8 raised to the negative 2 is 1 over 8 to the positive 2, or 1 over 64. So I can rewrite this as 8 to the 3x minus 1 is equal to 8 to the negative 2. Drop the base to get 3x minus 1 equals to negative 2. Then I'm going to add 1 to both sides to get 3x equals to negative 1. And then divide by 3 to get x equals to negative 1 over 3. Okay, and there's your answer there. Now let's see about 13. 13, I have log base 2 of 3x squared minus 11x is equal to 2. We're going to take 2 and raise it to the second power and set it equal to the inside, so that 2 squared is equal to 3x squared minus 11x. That means that 4 is equal to 3x squared minus 11x. Come over here and I'll write that as 3x squared minus 11x minus 4 is equal to 0. And then we're going to try and factor this. I think it'll be 3x here, x here, put a 4 and a 1. Let's make that negative and this positive. Then we have minus 1/3 and positive 4. And that is my solution set right there. Both of those values will work in here. So both of those are the answers. For problem 14, we're going to find the inverse of this function. Step 1, we're going to change f of x to y like this. Step 2 is we're going to invert the x and y, so I have x is equal 3 over y plus 6. Now we're going to solve this back for y, so I'll multiply both sides by y plus 6. Those cancel, and I'll distribute here a little bit to get, actually I'm not going to distribute, I'm going to write it like this: x times y plus 6 is equal to 3. Then I'll divide both sides by x. So y plus 6 is equal to 3 over x. So y is equal to 3 over x minus 6. Then you can say f inverse, that's really what we found here, that's what that means, is equal to 3 over x minus 6. By the way, you could write 6 as 6x over x, just putting an x in the top and bottom. So even though this is an acceptable answer right here, you could also have 3 minus 6x over x, which also would be acceptable, just by finding common denominators. Either one of this is a good answer though. For problem 15, we're going to go ahead and write this log as a sum and difference instead of big, the way it's connected right now. I want you to note that the cube root of 2x plus 2 can be written as 2x plus 2 raised to the 1/3. Now I'm going to write a log for everything on the top using a plus sign. And this is log base 3, and this becomes 2x plus 2 to the 1/3. And then we have a minus sign because that's in the bottom. Log base 3 of x minus 2 to the 3rd power. Okay, we would be done there, except it does say express powers as factors. That just means to put the exponents out front. So one last step. Log base 3 of x plus 1/3 log base 3 of 2x plus 2, and then minus 3 log base 3 of x minus 2. Okay, there's 15. Okay, for 16, we are going to use transformations to graph f of x equals minus 2 times x plus 2 squared minus 5. So we're going to start by graphing the parent function x squared. You can see that by the square here, and that's the standard parabola x squared. The first thing we're going to do is the inside, because we're going to follow this order called PEMDAS, which means we'll do the parentheses first, and that plus 2 will move it 2 units to the negative, because minus 2 plus 2 is 0, so it moves to the negative. It goes the other way than that sign says, so it moved over 2, so that's what I have here. Next thing will be the multiplication, so the minus 2 will first flip it over the x-axis, and the 2 right there will actually stretch it out a little bit thinner, so it will look something like this. You can use your graphing calculator to see the difference of these two functions. And then the last thing that's going to happen is any addition or subtraction. That minus 5 will just bring it down 5 units, so 1, 2, 3, 4, 5 units of that function straight down. And this would be, well, one of your answers, but you'll have to do all 4 graphs, and there will be graph paper, or actually little graphs on the test supplied for you, so you won't need graph paper. If you take a look at the answer key, you can see this exact same setup there. Okay. For number 17A, we are looking at a farmer who has 100 gallons of 70%. I'm going to put 0.7 there, just as a percent. And then we're going to have, he wants to mix it with some 90%, so x times 0.9, to get something that is 75, so 0.75, in which case he'll have 100 plus x down here. That would look like this in a real binomial. I just didn't have enough room there. Now multiplying straight across, you get, well, 70 plus 0.9x is equal to, this will be 75, let me make this a little bit bigger, plus 0.75x. And then you're looking at the last column, you get 70 plus 0.9x is equal to 75 plus 0.75x. So I'll subtract 70 first. So 0.9x, that's 0.9, is equal to, well, 5 plus 0.75x, and then we'll subtract 0.75x, and that will be 0.15x, that's a point, is equal to 5. So x is equal to 5 divided by 0.15, which is 33 1/3. Just do that on your calculator. So the answer is 33 1/3 gallons. Okay. Okay, for 17B, we have an alloy that has 30% silver, that's 0.3, and 55% silver, that's 0.55. We don't know either one of these values, but we know that it has to be 800 at 40% when we're done. So we're actually going to multiply across here to get 0.3x, 0.55y, and then 0.4 of 800 is 320. And then we have two equations, one right here, x plus y is equal to 800, and another equation here, which is right down here, 0.3x, let me make that better, 0.3x x plus 0.55y is equal to 320. I will change this to 30x plus 55y is equal to 32000, just by moving the decimal places 2 times or multiplying by 100, whatever you want to call it. Make that a little bit better. Look, that's a 5 right there. My 5s are having troubles. And those are both 5s. Okay, sorry about that. And actually, it's a negative. I mean, a That doesn't look much better. So 5s. Okay, don't shoot me for the 5s, but that's 55. Now I can put these together. X plus y equals 800. And 30x plus 55y is equal to 32,000. I'll multiply the top equation here by negative 30, the whole thing, and that's so that I can get the 30s to cancel. So I have negative 30x minus 30y, and that would be equal to negative 2,400, or 1,000, sorry. 1, 2, 3, 1, 2, 3. Okay, these cancel. 55 minus 30 is 25y is equal to 32 minus 24. That would be 8,000. And then we'll divide both sides by 25 to find out that y is 8,000 divided by 25. I'll do it on my calculator. I think it's 320 or something like that. It is. So 320. So that means right here we have y is equal to 320. I better write that up here. Y is equal to 320. Which means x has to be, well, whatever it takes to get to 800. So that must be 480. And then you can write your answer as saying 320 pounds at 30%, and take that back at 55%, and 480 pounds at 30%. Sorry for not writing that so neatly. These pens are getting hard to write with, but it's just basically this answer here, 320 at 55% and 480, and that comes from the fact that these two things right here have to add up to be 800. So I just took 800 and subtracted the 320. 320. Sorry about the bad handwriting. Okay, and that's just pounds. That's not a 16. That's just the pound signature. LBS. LBS pounds. Same thing here. LBS. Okay, don't think that's a value. And that's a 55% and a 30%. See if I can make it a little bit better. And that's just the word add. Okay. That's 17B. Okay, for problem 18, we're going to use A of t equals A sub 0 e to the kt, where A sub 0 is the initial amount, k is the growth rate, and t is time. And we're giving, first of all, that there are 100 to start with, so this is going to be equal to 100 for this problem. We don't know what the growth rate is, but we do know that it doubles in 6.5 hours. So what I might do is start this table and say time here in hours. 0 hours, there was 100. This is A of t. We can see that by the initial amount. And then in 6.5 hours, that's what it says, it doubled. So that means there would be 200 here, which means that 200 is equal to 100 e to the k times 6.5 for the t. Divide both sides by 100, so you get 2 equals to the e to the 6.5 k. Take the ln of both sides. Ln of 2 is equal to the ln of e. That's ln, by the way. My handwriting is getting worse. 6.5 k. That means that the ln of 2 is equal to 6.5 k, or k is equal to the ln of 2 divided by 6.5, which is approximately, when I put this into my calculator here, I'll do the ln of 2, close the parentheses, important to close parentheses, divided by 6.5, and we get 0.1066380.278. And I'm going to keep all of those numbers right there because I want to use them for sure. Keeping all of these right here. Because now all I want to do is set up my final equation here. Let me use a different color so you can see it. We're going to take the initial value, 100, e to this value of k, that's 0.1066, and there's a few more, but I'm going to just say this value right here, times a day and a half. Well, notice a day and a half in hours is, what is a day and a half? It would be 24 plus 12, or 36 hours. Notice that 1 day and a half, 1.5 days equals 36 hours. 24 plus 12. So that's why I have a 36 there. Then we just plug this in. 100 e raised to that, well, that value k, which is actually 0.1066380278 times 36. Make sure you keep that all in the exponent, and you should get 4,647.75 or 4,648, because we're going to round up, and that's your answer right there.